This is the first video about titration calculations. In this video we are going to look at how to calculate the concentration for a titration experiment. To carry out titration calculations, we need to know the equation to calculate concentration. So concentration equals number of moles of solute divided by volume of solution. There's no straightforward equation for these titration calculations. Rather, there's a series of 4 steps that we need to follow to carry out these calculations. So we are going to look at an example question and follow the 4 steps to do the calculations and answer it. 0.5 decimeter cube sodium hydroxide was titrated against 2 mole per decimeter cube hydrochloric acid. An average of 0.4 decimeter cube of acid neutralized the alkali. Calculate the concentration of the sodium hydroxide solution. Step 1. Find the mole ratio of acid and alkali, so hydrochloric acid and sodium hydroxide. To find the mole ratio, we need the balanced equation. Here we have the balanced equation. It's HCl for hydrochloric acid plus NaOH for sodium hydroxide reacts to NaCl for sodium chloride and H2O for water. We have to find the mole ratio for hydrochloric acid and sodium hydroxide. To find it, we have to look at the balancing numbers in front of the formulas in the balanced equation, and we can see that there are no numbers in front of HCl and NaOH, and this means that the mole ratio here is 1:1. So 1 molecule of hydrochloric acid will always react with 1 molecule of sodium hydroxide. So now we know the mole ratio. Step 2. Calculate the number of moles for the solution with a known concentration and volume. The solution with the known concentration and volume is the acid, so we know that the concentration is 2 mole per decimeter cube, and we also know that the volume is 0.4 decimeter cube. To calculate the number of moles, we have to rearrange the equation for the concentration. We can do this by timesing both sides of the equation with the volume of solution, and we get number of moles equals concentration times volume of solution. Now we just have to plug the numbers from the question into the equation at the bottom. So we get 2 mole per decimeter cube times 0.4 decimeter cube, and this gives us a number of moles of 0.8. So now we know the number of moles for hydrochloric acid is 0.8. Step 3. Use the balanced equation to work out the number of moles of alkali that react. We already know the mole ratio, so we do not need the balanced equation here. And the mole ratio of hydrochloric acid to sodium hydroxide is 1:1. So this means that 1 mole of hydrochloric acid reacts with 1 mole of sodium hydroxide. This also means that the 0.8 mole of hydrochloric acid that we have will react with 0.8 mole of sodium hydroxide. So the number of mole for sodium hydroxide is 0.8 mole too. Now step 4. Calculate the concentration of the sodium hydroxide solution. To calculate the concentration, we can just use the equation that we have at the top. So we have concentration equals number of moles of solute divided by volume of solution. The number of moles for sodium hydroxide we have found out now. It's 0.8. The volume of sodium hydroxide solution is given in the question. It's 0.5. Now we just have to plug those two numbers into our equation. So we get 0.8 mole divided by 0.5 decimeter cube. This gives us a concentration of 1.6 mole per decimeter cube for the sodium hydroxide solution.